Atlantic salmon start their life cycle in fresh water, migrate to saltwater as adults, and return once more to fresh water to spawn. Here on the east coast of Canada in the United States, Atlantic salmon spawn in the fall in rivers where they bury their eggs in the riverbed. These eggs hatch in the spring, and at this point, they are called alevins. The alevins stay in the gravel and have a yolk sac attached which they feed off. Once the yolk sac is absorbed, they develop into fry and come out of the gravel where they are first hatched. Near the end of the first year, they develop dark marks on their sides and are now called parr. They remain as parr until their third or fourth year, at which point they go through a change called smoltification that prepares them for living in salt water. The smolt will swim out to sea in late spring, early summer.
So farmed Atlantic salmon is actually very similar to wild Atlantic salmon life cycles. The only difference is that a farmed salmon is given multiple opportunities to grow. So we give them lots of food and we give them good water quality environment to grow in. We have a broodstock facility on land and fresh water. We remove the eggs from the broodstock in the fall, winter, and then those eggs will hatch, and the same, they'll have that yolk sac, they'll feed off of that yolk sac, and when that yolk sac is depleted, instead of the fry having to go and search for their feed, we offer that to them, and that enables them to grow a little faster.
Breeding salmon is very much the same as breeding other animals, whether it be pets or animals for food production. Once fish are born, we keep track of their parents, the broodstock, and watch how the children grow. We identify which fish are the healthiest and select only the best performers to breed again. By carefully tracing the strain of fish that are the healthiest and only breeding those families, we have seen significant improvements in the overall health and longevity of the fish.
The strain that we use here is the St. John River aquaculture strain, which was selected from the St. John River many years ago and is better able to survive and perform in the conditions that we face here on the East Coast. It was about 20 years ago that we decided we needed to better manage our broodstock and our egg supply to make ourselves more sustainable. Over those 20 years, those 5 generations, we've seen improvements in growth, improvements in flesh quality, which would include fillet yield, colour, and we've seen a much improved resistance to most of the common diseases that we face in this area. What we have here in Cook is a family-based breeding program. It's very similar to animal breeding programs with other species.
Genomics is the study of genes and their functions at the molecular level. Scientists look at how genetics and environmental factors contribute to growth and overall health. It does not involve changing the genes or DNA in any way. In aquaculture, genomics helps us better understand which fish will perform better in our environment and which fish are more disease resistant based on their DNA. This helps us choose which families of fish are best for breeding.
We've moved into the area of genomics to develop tools which allowed us to analyze the DNA of particular individual fish using the biological barcode that every animal carries. We can take a fin clip from our animals, we run it through these tools to better identify fish, and we can use it as the ultimate way of traceability so that we have a DNA fingerprint which allows us to have traceability from egg to plate.
Atlantic salmon spend the first half of their lives on land. As such, we have many land-based facilities in Atlantic Canada. Cook currently operates 15 hatcheries across New Brunswick, Newfoundland, and Maine, which stock all of our salmon farms in this region.
I'm a chemical engineer in training, and I guess what I like best is every day is different, and we're always looking at optimizing these processes to improve the overall water quality of the systems. The overall goal is to ensure that the fish are living in an ideal environment for good health and growth. Most of our facilities are recirculating aquaculture systems, which means they reuse the majority of the water in the system. So the water is treated and oxygen is also added so that more water can be kept in the system and less water is discharged into the environment.
Cook has been operating land-based salmon hatcheries and marine farms sustainably for more than 30 years. Hybrid systems involving a mix of land and marine-based fish farming will continue to be part of our future.
I focus on the water quality of the hatcheries. However, there are also managers, technicians, veterinarians, engineers, and maintenance workers that all work together to ensure the hatcheries are operating optimally to keep the fish healthy and happy.